Okay, um, so I'm making this video in response to Kiri's question about 27 part C and 29 from section 9.1. Um, so it was a little, I'm a little confused because the numbers that you were using, you said they came from 27C, but I think they actually came from 29. But that's fine. So I'm actually just going to work out number 29, and I don't think I'm going to do the whole thing. I'll probably just do like part A or something like that on number 29. But as you pointed out, I think that whatever issue you're having is probably the same issue on both sets of problems. I did sit down and try to crunch some numbers on 29A to try to get the same result that you were getting, and I couldn't make it happen. So I don't know exactly where you're going wrong, but I figure if I work this thing out from beginning to end, hopefully you'll be able to see maybe where you were going wrong. And if not, sometimes just a good night's sleep or something, kind of helps out. So maybe if you look at it with a fresh set of eyes to this morning, you might do a little better. Okay, so 9.1, so this is 9.1, number 29. I'm just going to work out part A. So this one says, low levels of testosterone in adult males may be treated using androgel 1.62%. In clinical studies of 234 adult males who were being treated with androgel, it was found that 26 saw their prostate-specific antigen elevated. The PSA is a protein produced by cells in of the prostate gland. Okay, part A says, determine a 95% confidence interval for the proportion of adult males treated with androgel who will experience elevated levels of PSA. Okay, well, so if you're working this out by hand, then the confidence interval you're looking for is P hat plus or minus your critical value Z sub alpha over 2 times the standard deviation of P hat, right, sigma sub P hat, which is the square root of P hat times Q hat over N. Okay, so there's the formula that you would use if you're doing this by hand. Now let me say, you don't have to do this by hand. You could do it in StatCrunch, okay? I'll work it out by hand because I think that's what Kiri was doing, but I'll also show you how to do it in StatCrunch here in a second. So if you were doing this by hand, then first of all, you would have to figure out what P hat is, right? So P hat is the number of successes over the number of trials. Here we're considering success, elevated levels of PSA. So there were 26 of those, right? So there are 26 successes out of the 234 trials. So 26 out of 234 is about 0.111 if I round to 3 decimal places. Okay, the next thing we'll need is Z sub alpha over 2. In this case, in part A, we want a 95 level of confidence, right? So if our confidence level is 95%, then that means alpha is 0.05, right? 100% minus 5% is 5%. 5% as a decimal is 0.05. Okay, so then Z sub alpha over 2 would be Z sub 0.05 divided by 2. So that's Z sub 0.025. And you would use StatCrunch now to get that value, right? You use the normal calculator in StatCrunch to do that. So we go to Stat, Calculators, Normal, Normal. We leave the mean at 0 and standard deviation at 1. We're looking for an area to the right. We want that area to be 0.025. And so our critical value is 1.96, okay? So far, so good there. I think we're ready to go. So we're ready to plug stuff into this formula now. We can say, all right, so our confidence interval is P hat plus or minus Z sub alpha over 2 times the square root of P hat times Q hat. Well, if P hat is 0.111, Q hat would be what? 0.889, is that right? Oh man, 1 minus 0.111. 0.889, yep. 0.889. Okay, divided by N, which in this case we said was 234. So we punch that into our calculator. I'm just going to do this part of it first. So I'm going to type in exactly what I see there, 1.96 times square root of 0.111 times 0.889 divided by 234. So I get 0.040. So I have 0.111 plus or minus 0.040. And then I do the subtraction and the addition, right? So 0.111 minus 0.04, 0.071. And 0.111 plus 0.04 is 0.151. Okay, so there's our 95% confidence interval if I were doing this by hand. Now we could be off by a little bit because we've done quite a bit of rounding. Okay, we rounded this value up here, we rounded the critical value, okay, we rounded this result, right? So we've done a whole bunch of rounding. The nice thing about StatCrunch is that it doesn't do any rounding in its calculations. It keeps the exact values throughout the entire calculation. So the answer you get from StatCrunch is better than this. It's more accurate. So let's see what StatCrunch will give us. To do this in StatCrunch, we're going to go to Stat, Proportion Stats, One Sample, with Summary. When we get there, we'll be prompted to enter something for the number of successes, something for the number of trials, and our confidence level. So number of successes, we said a second ago, there were 26 of those, right? Number of trials, we said there were 234 of those. And our confidence level, we said 95%. Okay, let's see what we get. So I'm going to go to Stat, Proportion Stats, One Sample, with Summary. We had 26 successes out of 234 observations. We want a 95% confidence level, so I'm not going to change that number. And then we hit Compute. And yeah, I mean, we get something pretty close to what we got when we did it by hand. In fact, if we round this to 3 decimal places, it's exactly the same answer. Okay, so to 3 decimal places, this is 0.071 and 0.151, just like we got before. Okay, hope that helps.